Good morning. Today we're going to work on functions and relations. Now, just a very short story in terms of the difference in functions and relations. The difference is kind of like, let me get these letters out of my face. The difference is kind of like the difference in a rectangle and a square. A rectangle, all four angles have to be 90 degrees. The two width ends need to be parallel and the same length, and the two length ends need to be parallel and the same length. Now that's their specifications. For a square, all of those specifications for the rectangle are true, except it has one additional special specification. And that specification is that all four sides have to be equal, not just the pairs of ends and top and bottom. So in other words, a square is a little bit more specialized than a rectangle. Likewise, a function is a little more specialized than a relation. Okay, anytime you have an x and a y value, you have a relation. But for it to be a function, then you have to have some specialization. Okay, here are some rules about that. Okay, we're going to determine whether something is a function. Okay, a set of ordered pairs is called a relation in x and y. Now, if the set of x values in the ordered pairs is called the domain or the home base, then the set of y values in an ordered pair is called the range or the outcome of the relation. In other words, you pick the x, it's the independent variable, it can be anything, and then the y value becomes dependent on whatever the x value is. Okay? For this table shown up in the top right corner. Got that cut off a little bit. And we'll see how that works. Okay, for the table up in the corner, this asks us to do three things. Write the set of ordered pairs that defines the relationship. Well, I put them here. The x value is 3, the y value is -4. -2, 0, 5, 3, and 1, 0. Now for part B, write the domain. The domain is just the set of x values, the 3, the -2, the 5, and the 1. You could order those, but you don't have to. Now C, write the range. Notice on the range, we got the 4, -4, the 0, and the 3, but we don't write down the 0 twice. We only write the number down once. So that would be the range of these values. Okay. Now we're going to determine if this set of a relation is a function. So the definition of a function. Come on. There we go. If you got a set of x and y values, we say that y is a function of x if for each value of x in the domain, the set of x values, there is exactly one and only one value of y in the range. Okay, so let's see what that means. Well, here's a graph. I'm going to draw a line through that graph. For this value of x right here, let's call this -1. In this graph, there is one and only one y value to go with this x value. Okay, now let's look at a nonlinear equation. Here's +2. Here is my graph. Okay, if we look at this, and my other pins are missing. In this case also, there is only one value, y value, for this x value. There's only one y value for that one. One for this one. One for this one. One for this one. One for this one, and so on. Okay, so this also is a function. Now, according to this criteria, what about if you had something like this? What if you had this? Okay. This is a graph where y is squared and x is a first power. Here, x is squared, y is a first power. Now, here, for this value of x, we'll call it -1, there are two values of y for that one value of x. That doesn't fit this rule because it says there can be one and only one y value for each x value. So this would not represent a function. Okay, we've got this set of points. I'm going to have to, this just isn't going to work. I'll have to leave it up there. We'll see what happens. Okay, we've got this set of points. X value, two different y values for the same x value. And not a function. Okay. Here, this is again showing we have the same x value, but different y values for the same x value. So that's not a function. In this set, okay, we've got 1, 2, and 3 as the x values. The x value here would be a 3. Now, we've got a 3 there, but does that fit our rule? If we graphed it, 1, 3 would be here. 2, 3 would be here. And 3, 5 would be up here somewhere. Now we've got kind of a goofy looking graph there, but as we see on this one, this x only has one y value. This x only has one y value. But this x only has one y value. So therefore, we would call this a function. Okay, what about these? Well, let's look at A. do we have the same y value with two of the x values? The answer is no. So yes, it is a function. What about B? Do we have the same y value with multiple x values? Well, I don't see any. Looks like each x value has its own unique y value. So yes. Okay, here's a set. This is called a mapping. An x value of -2, when you put it into an equation, produces a value of -y, -2 for the y value. An x value of +6, when you put it into the equation, produces a y value of +6. Now, any number is going to produce the same value. Okay? Basically, what that creates is that creates a line that goes like this. Okay? 6, 6, -2, -2, anything, anything. So yes. Okay, what about this equation? Well, yes. The fact is, this is called the point slope formula, or not, excuse me, this is called y = mx plus b, or one of the forms for a linear equation. And any line, just a plain line, will always be this, with one exception. That one exception to a plain line being a function is a vertical line, because then you have multiple y values for the same x value. Horizontal lines, no problem. Lines at any diagonal shape, no problem. Okay, what about this one? Here we see the x squared. So that's going to be a parabola or a U-shaped equation. Okay, but it's going up like this, and each x value is going to have its distinct own value. So that one also is going to be yes. I gave you an example of it a few minutes ago. Okay, this equation, we switched it around, move the 7 over with the x and change the sign of all three of these. That's just a standard line, happens to be going downward like this. And yes, it would be, because all lines are functions. Okay, now here, this one is going to be one that goes like this. Okay? Okay? Now, when x is first power, y is second power, it goes like this. If x were that, if it were this equation, which you could rewrite as y equals x squared minus 7 or plus 7, this equation could be written at that. This one would be one that goes like this. Okay, so if the x is squared, the y is not, goes like this. If the y is squared, the x is not, goes like that. Now, this one, yes. This one, no. Because whatever x value you've got, it would have two different y values to go with that x value. Now, to get 1y, here's how you could solve this equation. First, order it where the y is on the left, take the square root of both sides. Okay, and you've got the plus or minus. And that would not be a function, because what this is saying, that the y value is going to be, one is going to be a positive, one is going to be a negative for each x value. Okay, what about this one? This one's a y cubed. Now, for an equation that looks like y equals x cubed, that's an equation that looks like this. Okay, that's what this one is. Now, for this equation, we're going to have one that looks like that. Okay. Now, they're solving it. They isolated the y, they cubed both sides, or took the cube root of both sides, rather. Okay, this thing is going to be just as much as that one is, this one will also. Now, if I had a fourth power y, the answer would be no again. Okay, there's something called the vertical line test. That's what this says right here, the vertical line test. When you have the equation graphed, if you draw a vertical line through it anywhere, if it crosses twice, then the answer is no. For example, if I drew a vertical line through this, here or anywhere else, then there are two y values for the same x value. Two y values, 1, 2 for the same x value. So this one would be no. Okay, here's a quadratic equation or a parabola. Okay, in this case, once again, you still only have, with the vertical line test, only one value for each unique x value. So the answer is yes. Now, this one is what we call a piecemeal graph. It's got a piece of a graph and then it's got a piece of another graph. Here you see, because these are closed dots, that means that those values are included. Now, if that's included, then there are two y values for this singular x value, and the answer would be no. Now, if either of these was an open circle instead of a closed circle, then there would be only one x value, and the answer would become yes. So there are certain ways we can manipulate a graph to see if we want it to become a function or not. Okay, yes or no? Well, here's x equals 1, and you've got two different y values, so no. Yes. This one, we've got enclosed points in the same x value, so the answer is no. Okay, now we're going to apply function notation. Function notation is just a special way of writing things. Okay? This notation right here, we pronounce f of -3. Okay? That means we're going to try x value -3 in that equation. Up here in the equation, this says f of x equals 2x squared minus 3x plus 1. This is an equal sign. You just can't see it. Now, when you see f of x, you think y, because f of x and y are interchangeable terms, okay? Except one's just in function notation. So f of 3 means f, the function where x is -3. This means the function where x is the square root of 2. The function where x will be replaced by 3 plus z. The function where x will be replaced by capital A. So let's look at these. Here, I take my equation up there, -2x squared, or 2x squared minus 3x plus 1, and I replace all of the x's with -3. I simplify it, and I get 28. So the answer then is f of -3, and this is how I would like you to get in the habit of writing this answer. F of -3 equals 28. Okay? Now part B. We substitute in the equation the x squared minus 3x plus 1. Okay, we've got to do the square first, because the square only applies to what's next to it, doesn't apply to this. Square root of 2 squared is 2. I've still got the 2 times it. And here I get -3 square root of 2, and then plus the 1 on the end. This simplifies to 4 minus 3 square root of 2 plus 1. 4 plus 1 is 5 minus square root of 3 minus 3 square root of 2. I'll say it right in a moment. Okay, down here, I'm replacing the x with an a here and here. And there isn't anything I can simplify on that unless I wanted to factor it, and I don't. Here, I'm replacing the x with 3 plus z. This x with 3 plus z. I FOIL this. I distribute that. Okay, 3 times 3 is 9. -3 times z is -3z. And that gives me this, which goes on down here to the bottom, if you can see it. Which I'm getting in my own light. Positive 2z squared plus 9z plus 10 would be the answer on that. Okay, G just is notation, G of x just means it's a different equation. If f of x is one equation, G of x could be a different equation. So, G of x is 6 square root of 6 minus 2x. We want to know G of 3. So we replace that x in the radical with a 3. 2 times 3 is 6, so 6 minus 6 equals 0. Square root of 0 is 0. So our answer then, G of 3 equals 0. Okay, G of 4. We put it in here. That gives me -8. 6 minus -8 is -2. That won't break down any farther, so that's my solution. Now, why is that undefined? Well, what's the square root of -2? The square root of -2 is I square root of 2. And imaginary numbers can't be defined. That's why this is undefined. So there is no solution, no real solution for this problem. Okay, g of -4. G of +4 didn't work out very good. Well, let's try g of -4. Here I get, excuse me, here I get square root of 14. Square root of 14 won't break down, but it's somewhere between 3 and 4, approximately closer to 4 because square root of 16 would be 4. So that's probably somewhere around 3.7, 3.8 for graphing purposes. Okay, g of 2w. So we replace that x with 2w. Okay, so we distribute this and we get the 6 minus 4w, and that's as far as we can take this unless we know an actual value of w. We're going to skip through this slide. I will go ahead and do this one. F of t for the equation up there. That's it. Okay, this is f of t. So this equals -t squared because the square only applies to the t, plus 4t. And you can leave it like that. I suppose if you wanted to, you could factor out a -t like this and have t minus 4 if you wanted to. Or you could either make both of those pluses, and this would have to be the negative. But for the most part, right now, that's good enough. Okay, on the other one, we're going to replace it by a plus h. So f of a plus h equals -squared plus 4 times that, and I put a plus h in here, and a plus h in here, this odd looking a. So this gives me the negative I just bring down. This thing I've got to FOIL. A squared plus 2ah plus h squared plus 4a plus 4h, which I further simplify by bringing this out. I get -a squared plus minus 2ah minus h squared plus 4a plus 4h. And about the only thing that I could do with that is I could reorder it if I wanted to. -a squared plus 4a minus 2ah plus 4h minus h squared. Now, is this one any better than that one? Not really. F of a plus h. Okay. Okay, our next step, we're going to determine x and y intercepts of a function defined by y being equal to f of x. Okay. The intercepts are simply this. Okay. In this case, it has to be 0. Okay, the y-intercept, what this is saying, okay, what this is saying is that in a graph, the y-intercept, let's say right here it is, the y value, the x value always has to be 0 for the y-intercept. This would be like 0, 4, for example. Now, in a moment, we're going to have the x-intercepts up there. In the case of the x-intercepts, could be right here, for example. This looks like to me about maybe 3, and the y value is 0. Okay? So, what this is saying is for the x-intercepts, the y is always 0. For the y-intercepts, the x is always 0. Okay? Notice the difference in this notation. For the x-intercept, it's saying whenever you put in a value of x, you're going to have 0 for y. What this one is saying is you are going to substitute 0 for x, and then you'll get whatever for y. That's what this is trying to tell you. Okay, what about this equation? Let's find the x and the y-intercepts. Okay. Now, this is one way of doing this. This is not the only way of doing this. This is the hard way. If you make an XY table, for the x-intercept, y has to be 0. In other words, it has to be on the x-axis, not above, not below. So y has to be 0. So we just take this equation and substitute 0 squared minus 4. Okay, well, that's negative 4. Okay. So in this case, we would have that. Now, what they're talking about up there is, I did this wrong. If y is 0, then 0 equals x squared minus 4. Okay. And then this is what they did for the work on that. And you get the plus or minus 2. Graph-wise, that means you're going to have a value here and you're going to have a value there. When you have a second power, you potentially will have 2x values on the line. Now, what about the y-intercepts on this one? Okay, there may not be a y-intercept, or there probably will be. Now, for the y-intercept, well, let's just go through the slide and see what they do. Here's the y-intercept work. They are replacing x with 0 for the y-intercept. In other words, in my xy table down here, we're doing this. We got plus or minus 2 here, and we're doing this, okay? Well, the work for the y-intercept in this case is easy. Y equals 0 squared minus 4, which is equal to -4. Okay, so what that means for my graph is right down here is the point 0, -4. And this graph is going to go up like this. And it's actually going to go down a little more and up like this, because this graph has to have a line of symmetry at its lowest point where it's the same distance both ways. And I did a poor job of drawing that. The fact that it's in the middle of the scratch work doesn't help anything. Okay. Absolute value problem. Okay, to find the x-intercept, we replace y with 0. We replace y with 0. Remember, f of x, g of x is y. So we replace y with 0. And here's that. Okay, we take this 3 on the other side. Remove that, we have to do the plus or minus. And so we get x values of plus or minus 3. -3, +3. Okay, those are our x-intercepts. Now for our y-intercept. For our y-intercept, we substitute 0 for x. And so we substitute 0 there, absolute value is 0, 0. So we get 3 as our answer. So our y-intercept is +3. Right here. Okay. Now, the graph of this particular equation is going to look like this. Okay. Now, why is this one going downwards instead of upwards, like the ones we've all looked at previously? See here, the x value is negative. If the x value is negative, it will go downward. If it's, actually I drew the wrong graph. This graph and absolute value actually makes a perfect V, either inverted or otherwise. Now, what if this had been a plus right here? What if this had been a plus? If we had the equation h of x, I'm just going to make up a new equation, is 3 plus absolute value of x. Well, in that case, the graph of it would be here for the y-intercept still, here and here for the x-intercepts, excuse me. And this one would go up like that. Okay. What should we predict? We should predict some downward motion on this thing. Okay. For the x-intercept, we let y be 0. And we have to solve this for x. Take the 2 to the other side. square both sides, and we get x equals 4. Okay, the graph of that, x equals 4, 4, 0. There's the x-intercept. Now, the y-intercept, we replace x with 0, we solve it, and we get 2. So the y value is 2, like this. Okay? Now, what is this graph going to do? This graph is going to go like that. And we'll talk more about how and why and things like that a little bit later. That's not today's lesson. Okay, finding the domain and the range. We've said this before, the domain is the set of x values in the function, the range is the set of y values. Okay, what is the domain on this? Well, since this goes forever and forever, both outwards and upwards, then this goes from infinity to infinity for the domain. Now, what about the range? Okay, the domain, we always check left to right, what are the possible x values? For the range, we always go bottom to top, what are the possible x values? Well, the lowest y value, what are the possible y values? The lowest possible y value in this case is 2. Positive 2. The highest possible y value is infinity. Now, this 2 is included. So we have to use the bracket on that, so that would be our range. Okay, here is a piecemeal graph. What is the domain? Well, this goes out forever. This goes out forever. And because this point on x equals 0 has at least one value in it, then the domain is infinity to infinity. Now, let's play what if. What if both of these had open dots instead of closed dots? If this one also was an open dot, then our domain would be this and this with that actual value not included. So our domain would have been negative infinity to 0, union with 0 to positive infinity, if both of these were not included points. Okay, the range, the lowest point is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10 for a y value, and it is included. That goes to infinity with no breaks. Even though there's a break here, the fact that that break is filled in over here means that it just goes to infinity. Okay, this piecemeal one. Here, that point is not included, but everything to the left of it, so the domain, the set of x values, begins at negative infinity and comes back, but does not include this. However, because this is included here, then that point's included and it continues to go over to x equals 4. Okay? Because one of these two at least is included, then in the domain, that means they're both, it is included. Now, what about the range? The lowest point is this line y equals 1, or a value of y equals 1. There is a gap here with nothing in there, so we're going to have a union. And then we got included from 2 to 8. So we've got 1, and then that's union with 2 to 8. Okay, this one, our domain starts at -2 for x, and this continues out to infinity. Our range, this is going to continue not only out, but down to -infinity, making this the high point. 1, 2, 3, 4. And that high point is included. So -infinity is the low point, 4 is the high point. Okay, on these, the domain and the range, that's just a set of points. Okay. Well, you would have to have a point in brackets, union, a point in brackets, union 0, union 3, union 4 for the domain. What about the range? You would have set of negative, what is that? 1, 2, 3, union 0, union 1. Over here, -infinity to 4 and -4 to infinity. And with that, we've only got about 2 minutes left. So we'll go ahead and hold off on this until tomorrow. So that'll be our starting point tomorrow. We have actually done some of this already as I've been drawing these graphs for you. All right, well, have a great day and hopefully see you tomorrow.